So here we have CPM Precalculus Chapter 1, number 51. So here we're told Allison drove for a total of 2 hours. So Allison drove for 2 hours, right? And she drove 50 miles per hour, or mph, for the first 90 minutes. And then she drove 75 miles per hour for the last 30 minutes, okay? 90 minutes we know is equal to an hour and a half, so an hour and a half is 1.5 hours. 30 minutes is half an hour, or 0.5 hours. This is where 1.5 hours and 0.5 hours add together to get her 2 hours. Okay, so this makes sense. The first hour and a half, she's driving 50 miles per hour, and then the last half an hour, she's driving 75 miles per hour. So now we're asked in part A is how far did she travel? How far did she travel? So here she is in her car, right? I can draw. Okay, there she is. She's driving that car, and she drives a constant speed of 50 miles per hour, and then she increases that speed. So she goes from 50 miles per hour and 75 miles per hour. Okay, so distance. How far did she travel? Well, if we're given her speed 50 miles per hour, 50 miles per an hour. Okay, mph is just miles per hour, but it's really miles divided by hours, right? That's how in math and science is how we would write the quotient or the ratio of her speed. Okay, so we know if in 1 mile, right? In 1 hour, she can drive 50 miles if she's going 50 miles per hour. So how far can she go in 90 minutes? Well, what you have to realize is, I guess from physics you might know this too, but distance is equal to our speed times our time. And why is that? Because speed, or velocity with our direction, but speed is just distance divided by time, like miles per hour or feet per second. It's just the distance that you're going divided by the time. And time, of course, is t, and these cancel out, right? And you get distance. So what you need to just be careful to make sure is that distance over time, the time unit is in the same as the time unit that you're going to cancel it out with. Because if you are looking at hours, they do not cancel with minutes, right? But hours cancel hours. So let's just write this out. Her speed is 50 miles per an hour times her time is 90 minutes. Plus, then she goes 75 miles per hour times 30 minutes. Okay? And like I said before, the units here and here won't cancel out, right? Because hours doesn't cancel with minutes. But you know 50 miles per hour here. You know 90 minutes, we already said, is 1.5 hours. If you weren't sure, you could always go 90 minutes times, well, how many minutes are in 1 hour? We know 60 minutes are in 1 hour. This is just over 1. If you multiply this, you get 90 over 60 hours, right? Because these will cancel out, and you're just left with hours, and that's 1.5 hours. So if you didn't know exactly how to go from minutes to hours, you could just look at how to convert them. What is 1 hour equal to in minutes? And you can always figure out exactly how many hours that number of minutes is. So 90 minutes is 1.5 hours plus 75 miles per hour times 30 minutes is 0.5 hours. Okay. Then we just multiply these together. Remember, we have to do our order of operations is multiplication is before our addition, right? So 50 miles per hour times 1.5 hours is just 75 miles because the hours cancel out. If you weren't sure, you could use your calculator and just type in 50 times 1.5 and you get 75, right? Plus, we have 75 times 0.5. Oops. Again, if you want to check that out, you can just type it in the calculator. 75 times 0.5 is 37.5. Okay, so we have 75 plus 37.5 miles. And that's equal to, put in your calculator again, 112.5 miles. So how far did she travel? Allison traveled 112.5 miles. Okay, so part B. Part B is asking us to do what? B. Sketch a graph of this information using velocity in miles per hour and time in hours. Okay, so sketch a graph using velocity with units miles per hour and time using units hours or just hours, right? Shade in the area in the first quadrant that is under the graph. Describe the shape or shapes of the shaded region. Okay, so here's our graph. Our x-axis, our y-axis, but on our x-axis now we have time in hours, and our y-axis we have her velocity or speed in miles per hour, right? So time, this is 1 hour, 2 hours, half and half in between, so this is 0.5 hours, 1 hour, 1.5 hours, 2 hours. And our speed, we know it goes from, so let's say this is 25, 50, 75, 100. 25 miles per hour, 50, 75, 100. Okay, so the first hour and a half, she is going 50 miles per an hour, right? And then, after that, she goes up to 75 miles per hour. So then it goes up to here, right, like this. Oops. There we go. So this is a sketch of her traveling 50 miles per hour for the first hour and a half, and then 75 miles per hour for the last half an hour. Okay? Shade the area in the first quadrant that is under the graph. Well, we know quadrants, right? This is Q1, this is Q2, this is Q3, and this is Q4, right? In our X and Y axis, up here's Q1, up here's Q2, over here's Q3, over here's Q4, quadrant 4. So let's shade the area under, so underneath here, right? We're going to shade that. Okay, so describe the shape or shapes of the shaded region. Well, it looks kind of like a Tetris, so describe shape, shape, shapes of shaded region. Well, it's basically a rectangle here, right, and another rectangle here. So two rectangles. Yeah, I would just say they are two rectangles. You could even say like a Tetris shape. There's an S there, like a Tetris shape. You don't need to say that, but really, the shaded region is just two rectangles, right? Down here there's one, and then over here there's one. Okay? So what is the area of the shaded region? So that's part C. What is the area of the shaded region? Area. shaded region. Well, we know area of a rectangle. Well, let's look at this first rectangle right here. The area is going to be a rectangle, so the area, I'll call this A1, just because we had to do area of two of these and add them. The area is going to be, for a rectangle, just base times height, right? For any rectangle, it's base times height. So the base goes from 0 to 1.5, so that base is 1.5, and the height is 50. So the area of that first triangle is 1.5 times 50. You use a calculator, it's just 75, right? The area of the second triangle, right here, rectangle, is its base times height, and that's equal to, the base here is just 0.5, and the height here is 75. And we could use our calculator again, it's just 37.5, right? So if we look at the total area under that under the graph here, right? The area is going to combine both these rectangles, so area is equal to A1 plus A2. We're just adding the two areas. That's 75 plus 37.5, and that equals to 112.5. Interesting, right? Does anyone see that we just figured out, I'm going to go back for a second, that she drove a total of 112 miles, 112.5 miles in part A, right? When we're going back to part A, 112.5 miles. And the area under the curve is also 112.5. Does that area have units? What's the area? Well, it's base times height, so the unit here is 1.5 hours, and 50 is miles per hour. These cancel out. This is 75 miles. Again, this is 0.5 hours and 75 miles per hour. These hours cancel out, so that's miles. So actually, this is also 112.5 miles. The area has units of miles. So part C, the area of the shaded region, is really her distance, right? That's the distance traveled. Wow. Okay. Oh, actually, I just did part D. What D asks, I'm gonna put it here. What units are used for the area, right? So area units. Oops. Units. We know the area, again, is the base times the height, and I just did it there. So the base is our time, so that's hours, times the height is in miles per hour, and that's equal to miles. So the area's units is miles. So use the units for the height and the base of the rectangle to justify our answer. We did that. And this is the answer for part D. And this concludes CPM Precalculus Chapter 1, number 51.